Assalamualaikum and welcome to my video. So this is the part 6 for chapter 6, which is for gravimetric analysis. So if you look at this procedure for the gravimetric analysis, this part is the last part for this chapter, which is the calculation of the amount of the element or radical to be determined. So from the result we get from the gravimetric analysis, which is the precipitate. Okay, so the result of the gravimetric analysis determination usually is reported as the percentage of analyte. So percentage of analyte in sample equal to the weight of analyte divided by the weight of sample multiplied by 100%. So two value we need for this calculation, which is the weight of analyte or constituent desired and the weight of sample. So first, how to calculate the weight of analyte? Okay, so there are three ways to get the weight of analyte, which is the first is by using the chemical factor, the second one is by using the gravimetric factor, and the last one is by comparing the mole. So I will explain one by one. So for chemical factor, the calculation of the weight of a constituent in a given precipitate follow directly from the proportion MnAp, which is the molecular weight of the precipitate. Okay, weight. So this is the molecular weight for the precipitate ratio with the Nm. So m is the atomic weight. Okay, atomic weight or molecular weight of the element, and then multiplied by n. So n is the number, how many n, how many atomic, how many molecular weight for n in the molecule A, which is the precipitate. Okay, and then equal with W ratio with S. So what is the W? W is the weight of precipitate. Okay, basically the weight of precipitate is given by the question. Okay, and then ratio with X. So what is X? X is the weight of analyte or the constituent desired. And basically for gravimetric analysis, we need to calculate, we need to measure what is the amount of X. And next is by using the gravimetric factor. So by using the gravimetric factor, in general, the precipitate we weight is usually in a different form than the analyte those weight we wish to report. The gravimetric factor represents the weight of analyte per unit weight of precipitate. It is obtained from the ratio of the formula weight of the analyte to that of the precipitate, multiplied by the mole of analyte per mole of precipitate obtained from each mole of analyte. Okay, so for the formula, gravimetric factor equal for the formula weight of the analyte. Okay, formula weight of the analyte, we can calculate, we can measure what is the formula weight for analyte and what is the formula weight for precipitate by using maybe the data, the periodic table or the table for the formula weight. Okay, so formula weight for analyte divided by formula weight of precipitate multiplied by A over B. So what is A and what is B? Okay, so basically A is how many atom of analyte in the precipitate. Okay, and what is B? B is basically how many atom of analyte. Okay, so we see that later, and next slide I will explain how to measure A and B. So we look this example. So in this example, for example, for chlorine ion, so analyte is a Cl. Okay, analyte is a Cl, and precipitate. Okay, precipitate is silver chloride. Okay, so by calculation, we need to measure the formula weight for precipitate, which is the Fw for Cl, formula weight for Cl, and then we divide it by the formula weight of silver chloride. Okay, so in this calculation, you see formula weight for chloride divided by 1. So 1 here is the how many atom of chlorine ion. So chlorine ion got 1 atom. So the formula weight for chlorine divided by 1. The same for formula weight for silver chloride. So it divided by 1. So 1 here is the how many atom for chlorine. Okay, how many atom for chlorine in the formula of silver chloride. So if you see for the formula for silver chloride, it is a silver, 1 silver atom and 1 chloride ion. Okay, and if we look at the slide before, we can use also the formula weight for chlorine. Okay, divided by formula weight for precipitate, which is silver chloride. Okay, and then we can multiply by the how many atom of chlorine, okay, or precipitate or analyte in precipitate. So chlorine in precipitate on got 1 here. So we can multiply by 1, which is we measure from the precipitate how many chlorine ion in precipitate, and we divide it by how many atom in analyte. So analyte 1 analyte. So multiply by 1. Okay, so it's same equation between the first one, which is A, and B. Okay, so same equation. Okay, so we got after we calculate, we got the gravimetric factor for Cl here is 0.2474. Okay, so we look the last example. So P5O5. So P5O5 mmg2 P2O7. So we need to measure is how many atom for P2O5. Okay, so P2O5 we calculate by measure of how many P2O5 if 1. Okay, 1 here. So P2O5 got 2P. Okay, 2 phosphorus. And the same for Mg2 P2O7. So how many P2 in the precipitate? So it got 2P. So divided by the same 2 and 2. Okay. And if you look at the example, the easiest example to understand the gravimetric factor, so we look for phosphorus. Okay, I take the example phosphorus with Mg2 P2O7. Okay, with the precipitate. So formula weight for phosphorus. Okay, but divided by 1 because from analyte we got 1 phosphorus, and formula divided with the formula weight for precipitate, which is Mg2 P2O7, and how many analyte. So got 2 phosphorus in the compound, so divided by 2, or by using the calculation I explained before this slide, we can calculate by formula weight for phosphorus divided by formula weight for precipitate, which is Mg2, okay, which is Mg2 P2O7. Okay, and then multiply by how many analyte in precipitate. So there are 2 phosphorus in precipitate, so multiply by 2 over 1. So the same equation. Okay, and then we got the gravimetric factor. So we see at the last statement in this slide, the weight of analyte. Okay, because in gravimetric calculation, we need to measure one thing. Okay, which is the weight of analyte. Because the weight of sample sometimes it will be given for you in the question. Also the weight of the precipitate. So the weight of analyte you need to calculate. So by using calculation for gravimetric factor, so gravimetric factor multiplied by the weight of wedging form, which is the weight of precipitate. So you get the weight of analyte. Okay. So we see the example for gravimetry by for gravimetric calculation. So the first example, determination of iron, 2 positive. So 1 gram of iron compound after susceptible treatment produce 0.1565 gram of ferric oxide. Calculate the percentage of iron in the compound. So first you need to you need to state the formula, the ratio formula, because the first example here I explained about the chemical factors. So by using chemical factor, we put the equation, the ratio equation, which is the formula weight for precipitate, which is MNAP, and the ratio with an M, which is M is what analyte we want to determine. So analyte is Fe, so which is iron. So this is the iron, so Fe, and then N is how many iron in precipitate. So we see from the beside the ratio, so which is Mn. So Mn is the precipitate, Fe2O3, so they got 2 Fe or 2 iron in precipitate. So we multiply by 2. And then equal to W ratio with S. So what is W? W is the mass or the weight of the precipitate. So the weight of precipitate is 0.1565, which is in the question they are provide. Okay, and then ratio with S. So S is the mass of analyte. So the mass of analyte we need to calculate. Okay, so if you see by mathematical, if 160 ratio with 112 equal to 0.1565 ratio with what mass? So we need to multiply 112, we need to multiply by 0.1565 divided by 160. So we get the value for S, which is the mass for analyte. So the mass for analyte is 0.1095 gram. Okay, so we got the mass of analyte. So we can directly put the formula, which is the mass of analyte. We need to calculate the percentage analyte in the sample. Okay, so the weight of analyte divided by the weight of sample and multiply by 100%. So 0.1095 multiplied by 1 gram of sample in the question. Okay, so this in the question, the sample is 1 gram. Okay, so divided by 1 gram, multiplied by 100%, so we got the percentage is 10.95%. So next is by using gravimetric factor. So by using the gravimetric factor, we need to measure the gravimetric factor first. So the gravimetric factor is formula weight for iron, okay, divided by 1 here because how many analyte, so 1 analyte, so divided by 1, divided with the formula weight for precipitate, which is the Fe2O3, okay, and then divided by 2 because there are 2 iron analyte in the formula for the precipitate. Okay, and then with that we got the gravimetric factor 0.6994. So this gravimetric factor we need to multiply by the weight of precipitate. Okay, so the weight of precipitate is 0.1565. We got in the question. Okay, this is in the question. So we got the value of analyte, which is 0.1095 gram. So by calculate the percentage of analyte, okay, so percentage of analyte is the mass of analyte divided with the mass of sample multiplied by 100%. So we got the same answer by using the chemical factors, which is 10.95%. So we look at example number 2. Okay, calculate the percentage of bromide in the sample, which is 354 milligram that produce a tri-precipitate of AgBr within 187 milligram. So in this question, make sure you alert by the unit of the mass given. Okay, so the unit is milligram. So the easiest way is you convert the unit to gram. Okay, the best way if you convert to gram and you state what is the precipitate, what is the formula for precipitate, what is the formula for analyte. Okay, how many mass of precipitate, and you need to measure what is the mass for analyte. So by using gravimetric factor, so gravimetric factor is formula weight for Br. and then we divide it by 1 because there are 2 atoms in analyte, and divided with formula weight for silver bromide, which is ADR, which is the precipitate, and divided by 1. So how many bromide in precipitate? There are 1 bromide, so divided by 1. So we got the gravimetric factor is 0.4255. So this gravimetric factor we need to multiply by the weight of precipitate, and after we multiply with the weight of precipitate, we got the value for the mass of analyte. So in this question, we got the mass of analyte is 0.07957 gram. Okay, so I already convert into the gram unit. Okay, so by the percentage of analyte, so percentage of analyte is 0.07957 divided with the mass of the sample. So the sample, if given, is 354 milligrams. So make sure you convert into the 1 unit. So gram is 0.354 gram, and multiply by 100%, you got 22.48%. And the same for by using chemical factor, you can using the chemical factor. So by using chemical factor, you got the same answer. Make sure you understand. And the chemical factor, you need to make the ratio, and by the ratio, you need to understand. Okay, if 188 by ratio is 18. So if your new ratio is 0.187, so what is the value of x? So the value of x is 0.187. Okay, so this one you need to multiply with the value for nm. Okay, so nm is 18, and you need to divide it by the unit for MNAP, which is 188. So you got 0.07957. So this is the x value, which is x is in the unit of gram, and x is the mass of analyte. So by percentage of analyte in sample, you can calculate the same like the gravimetric factor, which is the mass of analyte divided by the mass of sample, and then multiply by 100%. So you got the same answer, which is 22.48%. And this is the example number 3. So this example number 3, I will explain by using, by comparing the Mohd method. So this is the another method others than by using the gravimetric factor or by using the chemical factor. So we look at this question. In one gravimetric analysis, the aluminium in 1.2 gram of sample is impure, NH4AlSO42 was precipitated as anhydrous silver oxide anhydride. So the precipitate was filtered and ignited at 1000 degrees Celsius to give the anhydrous Al2O3. So this one is the precipitate. Okay, so this precipitate, the mass of this precipitate is 0.1798 gram. Okay, so calculate the percentage of Al. So this percentage of Al means calculate the percentage of analyte in the sample. So what is the mass of sample? So the mass of sample is 1.2 gram of sample. So by using this data, okay, first you need to, if you see the how to calculate, so we need to know how many mole of the precipitate. So the mole of precipitate, the mass of precipitate are being given. So you need to divide the mole of the mass of the precipitate given divided with the molecular weight for the precipitate. So Al2O3, the molecular weight is 102 gram per mole. So you got the mole for the precipitate, and then we compare. Okay, we compare the precipitate and the analyte. So from the precipitate, we see there are 2 atoms. Okay, from this precipitate, there are 2 atoms of aluminium, which is from 1 mole of precipitate, it will produce 2 mole of analyte. So the same situation, so 1.763 multiplied by 10 power of minus 3 mole of precipitate will give you, so you need to multiply by 2. So we give you 3.526 multiplied by 10 power of minus 3 mole of analyte. So this is the mole of analyte. So by using the mole of analyte, you can determine the mass of analyte. So how to measure the mass of analyte? So this mole, you need to multiply by the mass, the molecular weight of analyte. So molecular weight for analyte is 27. So you got the mass for the analyte. So by using the same equation for chemical factors and gravimetric factors, after you got the mass of analyte, you can divide it with the mass of sample and multiply by 100% to get the percentage of analyte. So after you do that, you got the percentage of analyte, which is 7.93%. Okay, so how about the gravimetric factor? How about the chemical factor? So you can try to do the exercise. You can try by using the gravimetric factor and by using the chemical factor, and make sure you got the same percentage, which is 7.93, and make sure by using the gravimetric factor and chemical factor you use the same molecular weight. Okay, for example, molecular weight for Al for aluminum I'm using is 27, so you need to use the same molecular weight, which is 27. Okay, for example, I'm using for Al2O3, I using the molecular weight is 102 gram per mole, so you need the same, which is 102 gram per mole, because sometimes reference give you the different point, okay, different value for atomic mass, so you need to alert by atomic mass. So that's all for chapter 6. So have fun study this chapter and good luck. So thank you very much.